So, what are we going to do today? Our goal is to show you how to focus on your code and not your infrastructure. So, more generally, how to use the tools that you are already using every day in conjunction with hosted cloud products to remove extra burdens and tasks on your IT and engineering teams. So, if you are at a media company, your focus is on creating and serving content, the media. If you're in education, your value is teaching. You're focusing on educating. We don't just spin up servers and put people on call just for the fun of it. Everything we do is for a business value. So instead of starting out with product summaries or architecture diagrams, I'm going to take you in a story in 3 parts, and then we will uncover the pieces of technology and define them as we go. We are even going to add a little machine learning at the end because I know that's really just what everyone wants to see today. So our story today revolves around Alice and Bob. If you've ever taken a computer science class, read about cryptography, or even just seen enough of these conference presentations, you might have noticed Alice and Bob they're pretty busy. They show up a lot. This is an aside. I just thought this Wikipedia article about Alice and Bob in science and engineering literature is hilarious. They made their debut in the 1970s in an academic paper, but today, for today's story, they own a brick and mortar shoe store. So it's a small operation. They get to manage sale prices in-house. All the employees involved with shipments can do all their basic inventory management in a sheet. So they track things like the shoe, what price they want to sell it at, whether it's in stock or if it's still in the warehouse, what it looks like, and vendor information. Maybe there's another sheet with the availability per shoe size. Some vendors have their own websites. And if they don't, they just make a Google Doc with all the information that they need to store when the shipment comes in. So why a sheet? Everyone can collaborate and they can always have the most up-to-date information. It's an easy system, relatively easy system to use with no additional setup. It's not like a custom app or interface that someone had to write and then maintain. Then they can also get insights from their data, make charts, try to get a feel for how the store is doing at any given time without having to invest in like a custom system, proprietary system for this. I actually worked retail in high school, and at sale time, we would get reams of this continuous printer paper with all the SKUs and new prices, and then we'd have to run around the store marking things down. And if there was a mistake, we would just have a bunch of sticky notes up at the register. There's a lot of wasted time doing this. This is exactly what Alice and Bob are trying to avoid. They don't want all their employees running back and forth between the showroom and then the warehouse or the back room. But we have a problem here. The data as it is right now, it's pretty tedious to go through. It's difficult to manipulate. It's not actually consumable by the employees on the store floor with their devices. And if the store is busy, we don't want a customer waiting in line for the only computer up at the register. Maybe a price tag fell off and they just need to do a price check. So Alice and Bob are close, but this doesn't quite solve their workflow problem just yet. They want to prototype a better way to use their new devices. So they know a little bit of HTML, JavaScript, CSS, all that good front-end stuff, and they prototype a mobile-friendly web client. So it's an experimental idea. They don't really want a crash course on Android or iOS development just yet. They just want something simple that they can get up and running in an afternoon. So this solves a lot of the issues we had in the sheet. The images are already rendered, and they don't need to do some extra filtering to see what's in stock or in the warehouse. So that was a mock. How do we actually serve this web client? Where do they start? They do a little bit of research into a typical web architecture. It's really not just a client and server, right? If you want to have things like fault tolerance or high availability, you're going to need some more stuff, like maybe you have a load balancer to handle all those multiple servers, or if you have a database, maybe you need a cache. Then after they set all this up, they'll have the maintenance burdens of dealing with things like networking, Security, who upgrades all those operating systems and installs security patches. And then after that, they need to do some resource management and forecasting. What happens if they want to expand and get multiple locations? If they go into the cloud the traditional way, there's still a lot of configuration they need to do for all those virtual machines. They no longer have to manage the physical machines, but they do have to keep everything in sync on top of them. Then you start to have to think about how to handle spikes in traffic. Do we need a task queue to absorb requests if we are spinning up more resources? Really, all they want to do is focus on their code, none of this stuff. So if you're sitting in the audience today, this really probably doesn't seem like a daunting task, and you've already bought into cloud computing. Otherwise, this would be a very expensive waste of a ticket. We're using this simple brick and mortar example to illustrate that you don't actually need a specialized stack for every service or workflow in your business. There's a lot of different trade-offs to consider when you're designing infrastructure, and we want to show you that you can have scalability, reliability, fault tolerance, all those things that we really like, with a much simpler stack, and how to glue all your existing services together. So let's finally define serverless and see when it makes sense. It's been described before as invisible architecture. So it's a platform, it's a collection of services that allows you to write and deploy code without having to manage or really know anything about the machines underneath. So the trade-off you're making is that you give up more of that fine-grained control to have your cloud provider handle all that machine management. So they don't have to deal with things like installing security patches, like we mentioned earlier, attaching disks, dealing with memory, load balancing. Serverless scales for you. So as your requests come in, it'll scale up. But then on the flip side, serverless will also scale back down all the way to 0. So you only pay when your code is actually executing. If your code is only running for 5 minutes a day, you only pay for 5 minutes a day. Alice and Bob really like this because they really only need the service while the store is open, right? And they don't want to pay for VMs just sitting idle running all night. We're going to look at some code later. Where it says open, all that really means is that you can use the languages, the tools, and the frameworks that you're already familiar with. So if you're using Node, which we will be doing later today, you get to use the Express framework. If you're using Python, you use Flask, and so on and so forth. The most well-known product on our platform in serverless is App Engine. But Alice and Bob don't even really need that. They just need a specialized function to serve their data, which is how we end up at Cloud Functions. So Cloud Functions in a nutshell is that they are narrow bits of code that you upload to Google. Then GCP figures out how to place them and scale them for you, and then you trigger them by events. So I mentioned Node, Python, there's also Go, and I am actually excited about Java because Java was my first programming language, and it's still kind of my default. This year, we are using Node 8, which is nice because we can use async await. So more about Cloud Functions. So there are 2 different variants. We have HTTP functions, which are more common, but then we also have background functions. So HTTP functions, they are triggered by HTTP requests. You can either call them from a browser or an API, so that makes it fit in really well with like your REST JSON APIs. So they're good for events like payments. Maybe you need to talk to Stripe. Texting. Maybe Alice and Bob want to use Twilio to send notifications about sales to their loyal customers. They work well as callbacks where you need to do a little bit of work, maybe talk to an external service, and then you just get a response when all that work is done. There is also an integration with Cloud Scheduler and Google Assistant. The second type of function, they are background functions. So they are responses to cloud events. They're very different than an explicit human interaction. So one example is cloud storage. Maybe you want to do some analysis every time you save something to one of your GCS buckets. So you could wrap that analysis in a cloud function, and then it'll execute automatically without any human intervention. So let's look at HTTP functions first. Here is our hello world. So I keep saying function. Do I actually just mean a function? Yes, with like one line of real code, we have like a fully capable backend. So what we're doing here is we're just setting the response code. We're good. And we send back the text that we want to display. If your HTTP request has any query strings or any values in the body, maybe you're making a post, you can also get those and read those in the function. Then Cloud Functions handles creating a fully provisioned endpoint with security certs, and you don't need anything else like a gateway. You can just navigate to that endpoint. So what do Alice and Bob need their function to do? Hello world just returned some string. They need to read the data from the sheet, and they need the data in a format that can be rendered by the web app. So there's some of our data. It's in JSON format. That's what it's going to look like when it's coming through the wire. But how are they going to get it? By using the Sheets API. Who here has used the Sheets API? Awesome. Okay, that's great. So it is a service to programmatically read and write sheets, and then you can do other things that you can do in the UI, like add charts and formatting. You can use this client library anywhere that you would be running code. So, on your laptop, maybe your desktop, on your on-prem servers, or even another cloud provider. Sheets is actually just one of the full family of G Suite APIs. So we have APIs for daily tools such as Gmail and Calendar. We actually just launched the Docs REST APIs back in February. So maybe down the line, Alice and Bob want to automate their invoicing. You'd use it for like bulk document creation. So Google Cloud is both GCP plus G Suite. You use the same accounts, and you manage both in the Cloud Console. So turning on Sheets looks the exact same as turning on Cloud Functions. So using them together is how you get more for the cloud that you're already paying for, because you can bring that and make it more accessible to other people in your organization. If you still don't know what G Suite is, it is the family of these productivity tools. So most people are familiar with those day-to-day tools. But over here, we also have the admin SDK. Do we have any IT or domain admins here? Okay, yeah. So this is what you would use to manage your users, and you can get reports of the activity within your domain. So they're using Node. They sit down, set up their Node environment, and then they do npm install Google APIs. Google APIs actually has a lot of stuff in it. It has all the G Suite APIs, as well as like ads and YouTube. But today, they just need Sheets. So how do we use that API? I know this is a lot of code, but we're going to step through it together. So the first thing that we see is our scope. All we're really doing is we just need to read the data from the sheet. So we request read-only access. If they were to drop the read-only, that would be right, but it's best practice to request the most restrictive scope. We don't want something going haywire and starting to write to sheets. Most people actually use a Drive API because there's a lot more scopes and they're finer grained. Yeah, so for you IT admins out there, you can decide what type of access your apps have within your domain, and you can block what you consider as risky by what these scopes do. So the next thing we do is we create our client for talking to the sheet, and we only need two things. We need the ID of the sheet to read and where to actually read within there. So that file ID that we see, it's that same file ID that we would see if we were looking at a sheet in a browser. And then range, that is A1 notation. That's how we say, just give me all the data in the first 5 columns. It doesn't matter. You don't have to know how far down the data goes in those rows. Sheets will handle that for you. So then we make our call. Then we do a little bit of node magic, and we get a map, and that's all our helper for reading a sheet does. So that was reading sheets. Now they know how to do that. They need to actually wire up their cloud function. So this is a cloud function. All it does is call that helper that we just had. It sets a 200 response code, and then it declares that we're sending JSON. Today, we are only looking at the backend code. All that nice HTML, JavaScript, CSS that we talked about earlier, that could be served by either another cloud function that would be like our client, or maybe they're using App Engine. Either way, that client code is calling this cloud function because this is our backend. So we put both of those pieces of code into our cloud function. You can manage your functions in the cloud console. You can even edit them right there in the browser. It has nice things like syntax highlighting. You can upload multiple files. You can see on the other tab we have package.json. So that's how we do dependencies in Node. In my opinion, it's good for quick fixes, but it's still easier to develop in your own environment. So they are ready to test it out. So they deploy it. There are 2 different ways to deploy cloud functions. So the first way is you can do everything right through the browser, or you can use gcloud to actually upload it. So gcloud is that tool that you use to manage all your GCP tasks. Both ways, you just give us the source, and then we build in the cloud on your behalf for you. Once your function is deployed, you can actually go back into the console and do some neat things, like you can test it out with like triggers that you put in the browser, or you can look at the logging. So the function is deployed. Functions gave us this fully provisioned endpoint on the default domain. It doesn't have to be, but there is no extra setup. We just go to the browser, and then we see our data in a consumable format. There is one extra piece of setup I want to mention. So G Suite is really meant to be used by end users like me and you, right? But then our function is run by a service account. Service accounts are the identity of our code that's running. So it's nice because like that function doesn't have to run as alice@gmail.com. She doesn't actually have to add herself to this. But we add that service account to this sheet. So in our code, we gave the capability to read sheets, and now we're sharing access to this specific sheet. This is where you'd find the service account. It's in the console. When you enable cloud functions, it actually gets one for you. So this is the last part of the setup. Let's see what they just built. So our data started in the sheet. Then we added a function to transform the data to JSON. And then, voila, every time a store employee goes to their internal site, they get the inventory data right at their fingertips. So no more extra trips between the stock room and the floor, and only 30 lines of code, a little bit less. They have a complete backend. Remember our inventory function, because we're going to keep building on this, but this completely handles their server-side needs. So this prototype works well. Employees get to spend more time with our customers. The sheet works well for now, but they do need to be conscious about scaling issues. It is actually faster to read from a database, and they need to be conscious of their sheets quota because they're hitting this API to read every time the page loads. So Sheets is a great product for collaboration, analysis, visualization, but it's not a database. They want a little bit more access and security control. They want indexes. It's not really designed for querying. The sheet isn't going to go away, but let's see what Alice and Bob look into. So they go check out the portfolio of storage options. So there's a variety of stuff in here. We've got a lightweight cache. It's not exactly what they need, so they need a database first. Then we have some non-relational and relational options. And we also see BigQuery here. That's a pretty heavy-duty solution. It is a relational database, but it's mainly for big data and analytics. They really just need something in the middle, right? I do want to point out Firestore because that is a serverless storage option. It's serverless because it handles the provisioning and setting up your instance for you, and it scales. You only pay for what you're actually storing. They want to go with something that they're familiar with, good old traditional MySQL, which is why they go ahead and pick Cloud SQL. So this is a product where you can host your MySQL and Postgres instances in the cloud. Then you manage them the same way that we're managing our functions in the console. So luckily, Alice and Bob get to start from scratch with this simple schema. But if they needed to migrate an existing database, there's a lot of info on how to handle that replication and minimize downtime during that transition. So we have the sheet and we have the database. Let's fill in what goes in the middle. The team really likes to use the sheet, and they're not going to learn SQL, and Alice and Bob don't want to build another interface just for, like an admin interface for the database. So they keep the sheet, not as the source of truth, but as the input mechanism for new shipments and price updates. So how are we going to move the data? We add in another cloud function. So we add a function called start export, which reads the values from the sheet like we were before, and then it either inserts or updates those rows in the database. But how does a team kick off that export? When does it happen? We can trigger the cloud function right within the sheet. So we can create a custom menu which triggers that HTTP request to start the export cloud function. So let's see how they do that. How do they get this nice custom menu item? With AppScript. So AppScript is serverless as well. AppScript is a JavaScript runtime in the cloud. It has built-in libraries for G Suite products, so it makes it really easy to automate, extend, and integrate. That's how we can integrate directly into that UI. My favorite part about AppScript is the automatic authentication for OAuth. So it automatically detects those scopes that we were looking at earlier. It manages your access token, it refreshes them for you, and it sends users through the authorization flow for your apps. So since AppScript is serverless, it is also triggered by events similar to Cloud Functions. In our case right now, we're using the UI as the explicit trigger to manually trigger our task, but there's other options that would work well. I want to call out on edit, so that would just tell you what has actually changed, but they mainly update in batches, which is why they want to go with an explicit export of all those rows. There are multiple entry points to the AppScript editor. You can open it right from inside the sheet. This is also the same for docs and slides. So this is what our script editor looks like. Our AppScript just does two things. So first is installing that menu item that we saw before and tying it to some code that we want to execute. So then the second is what we want to execute. And all we're doing is we're going to that URL for the export function. So that's all set up now. Let's recap what they have. We start with Sheets as the input mechanism. When the data is ready for consumption, the employees start the export using that custom menu in Sheets. Next, the Cloud Function start export either inserts or updates those rows in the Cloud SQL database. And then, last but not least, we still have inventory, and they update inventory to read the data from the database now and then serve it back to the web client. So our diagram is starting to get more parts and starting to get more complicated. But honestly, there's not that much code between these two functions. In fact, if you were doing this in like a traditional server model, these would just be two methods. But now that they are separate cloud functions, you can update and deploy them independently. So if they grow their data, I would consider there to be a risk of timeouts and failures in the start export function. So, it's reading that whole sheet and then it's doing all those database operations. You'd probably want to add some logic for retrying. But There's a lot of other products that do that for you, and Alice and Bob really don't want to reinvent the wheel. So let's see what we can add there to make the data transfer more reliable. So remember that we had two cloud function types. The second is what we're going to investigate now, background functions. And transferring data is exactly what this is used for. So we have PubSub. Has anyone used PubSub before? It is a messaging bus, and it stands for publisher subscriber. So let's look into this. So if you have a stream of data or events and you want to pass them between services, you can use this as the mechanism. So in our case, the stream of data are the rows from that spreadsheet. And then PubSub streams those messages, and each shoe and its corresponding data is an individual message. So we'll briefly talk about the different parts of this product, then we'll apply it to this app. So the publisher sends a message to the topic. The topic is just how we categorize all these messages. And then subscribers receive the message and then probably kick off some work to do with that data. You can kind of think of it this way. So let's say that this slide deck it's a stream of data, right? Let's say that each individual slide is a message. So you all are subscribed, you registered to listen to this topic. This topic is serverless from the ground up. And I am publishing this data to that topic. It's the same principle as if we're talking about servers talking to each other instead of humans. What's nice about PubSub is that it guarantees that your messages are delivered to the subscriber. And how it does that is it waits till each subscriber acts a message, then it'll keep retrying. So if your subscribers are down, you don't have to worry. All those messages are guaranteed to be delivered at some point. So in our example, we have one publisher and one subscriber, but it's many to many, so they can scale up if they need to. We don't want our export function to be like a long-running operation and stream the entirety of their data. So export now breaks up those individual rows, and then there's a background function that receives them, and that background function, on receiving the message, inserts them into the database. So now that we've added PubSub, let's do another recap and see how the data flows through our system. So we start with the sheet and app script. Start export now reads the sheet and creates an individual PubSub message for each row of data. The function, the data now goes through PubSub, and then it's received by a cloud function, update shoe, and that cloud function, all it's responsible for is updating an individual row. Then we finish out the same with good old inventory. It still serves the data to the web app, and now it's reading from the database. So we have the same system, but with a little bit more reliability. So it looks like we just threw in a whole bunch more icons and arrows. So I want to review exactly what we just did. So the whole point was we wanted to add a database. So then after we added the database, we just needed to link the pieces together. So we added a trigger to kick off the export. Then we added a background function to actually do that updating in the database. And we still have inventory from V1. It just serves the front end. These are relatively short snippets of code, and what they're really doing is that they're serving as our glue. They're linking our systems together. And now that they're separated, they can be maintained independently, and they don't block each other. So we don't have to take down the inventory function just because we want to change the way that we read the sheet, and vice versa. More importantly, we can scale them independently. So if you remember our function that only updates a single row in the database, it probably doesn't need that much memory, right? So we don't have to scale up the entire system for any of the functions that do require more resources. So we talked a lot about transferring data. Let's do something a little bit more fun. There are a lot of different ways to integrate different GCP products into your system. Machine learning is a very hot topic right now, so let's dive into that ML and AI section. So GCP has a number of services that use ML for like speech transcription, analyzing text, video analysis. I don't know much or like at all about machine learning, but I do know how to use APIs. And a lot of these services use pre-trained models to give you insights into your data. So Alice and Bob hear about this, and they want to see what they can get out of it. They would love for a way to search for attributes of a shoe for a customer question without having to scrape the vendor information or manually curate what they think is important per item. Loyal shoe store employees have a different bias than picky customers. So they want to automate this. So they look into the Cloud Vision API. This API uses pre-trained models to detect the interesting things about an image. So faces, text, and labels. And labels is kind of a catch-all for, it could be the object, it could be the product, the location, the activity, and more descriptors like that. So let's look at an example. They run Cloud Vision on a sample shoe. And Cloud Vision decided that these are good for walking in the outdoors. I had to look up what carbine was, and that is a very specific shade of red. So they want to do this for their whole stock and incorporate it into their web app. So how do you think we're going to add this? With another Cloud Function. So we're using Cloud Function as the glue to integrate this into the system that they already have. So the API is really easy to use. You can do exactly what we just showed you in the previous slide in really only a few lines of code. Since it's in the GCP family, you don't need any extra setup or authentication. You just create a client, and then you run label detection on it. This is what it looks like when it's hosted. And all this code that I've showed is on GitHub, so they're not doing any demos. So when they are actually incorporating this into their system, they would probably add a little bit more code to filter out tags like footwear and shoe and only store the interesting ones. So they can attach the function into their data flow and then save the labels in a separate table in their database. And then magic, their web app is now also powered by machine learning. With just a few tweaks to the UI, the store employees can now look up what shoes a customer might be interested in. Even the really picky customers, maybe someone comes in demanding carmine red shoes. So we only have a few minutes left, so let's recap what we touched on today. This is what we started with. And then with a few functions, a little bit of glue, this is what we got to. So in just a couple hundred lines of code, we turned a sheet into a whole backend service with reliable data transfer to a managed database. Most importantly, it's still user-friendly without having to build a second interface. Sheets is easy to use, and then they added a little bit of embellishment with AppScript. And then they got more value out of the data that they were already storing by using Cloud Vision without having to change the core system at all. So that's the point of serverless, is that you can scale and add these microservices independently. If we were to scale this example up to something that you would actually be doing at one of your companies, you can imagine that each one of these functions or the services that the function called is managed by and run by a whole team of developers. So now they're not blocked by each other, and those teams can work independently and release on their own schedules. So it is your turn now. Like I said, the code I showed today is on GitHub, and you can let me know what you think by tweeting at me, and I am excited to answer your questions. Thank you.